Welcome to the Elevator 5 final project. In this project, you will be able to see a lot of advances. We have our final implementations and connections, as well as some changes to the original code. So let's continue with the explanation of the part and connections, functionality, and the coding section.
Our elevator system uses two Arduinos.
On the main Arduino, floor buttons are connected to pins 2, 7, elevator indicators to pins 8 to 11, servos to pins 12 and 13. The second Arduino communicates with the main 1 through analogic pins A0 and A1. It also includes a switch connected to pin 12 located on the lower back section of the elevator. The system uses two high-torque servo motors to open and close the elevator's doors. On the top of the elevator, there is a mini breadboard that holds 4 neopixels and 4 push buttons, each with its own reading. These components share a common ground connection. The 6 flux buttons and the neopixels also connected to a single ground point and are wired directly to the main Arduino. The start motor and the secondary Arduino have their own power supply, while the main Arduino is powered directly from the computer.
Finally, the elevator's door mechanism represents another crucial component for user interaction and system safety. To achieve the necessary horizontal opening and closing movement, we implemented a rack and pinion system driven by two high-torque servo motors. The selection of high-torque servos was essential to provide the required force and maintain the constant speed needed to reliably move the physical rack assembly during every operational cycle.
See that if we push the reset button, it goes down to floor 1.
Then if someone enters on the first floor and the door closes, and then they press that button, they go to the second floor. Now if they want to go back to the first floor, but someone on the third floor wants to go to the second floor, it will go to the first floor and then go back to the third floor. The door opens and they pick that person up. But then there's a person who is on the third floor, who wants to go to the fourth floor. It'll first start to go down. Then it'll drop that person off and go to the third floor. Doors open. Then it goes up to the fourth floor, and the person on the fourth floor wants to go to the first floor. The doors open. It picks that person up. And they press the first floor button, and now they're going down. That person is now on the first floor, and then the door opens, and they get out.
As we added more and more functionalities to our elevator, we ran out of digital pins, and we figured out a different solution.
Our elevator solution relies on a sophisticated master-slave architecture utilizing two Arduinos connected via the I2C protocol. The master Arduino acts as the command center. Its role is purely logical and mechanical, constantly reading all internal and external floor buttons to determine the next destination. Conversely, the slave Arduino functions as the dedicated interface manager, exclusively handling feedback to the user. Its entire operation is centered around waiting for data. It receives an index and color value sent from the master over I2C to instantly update the alight strip.
And fundamentally, you can see that with this new implementation, we're dividing our code between two Arduinos. Over here, we're going to handle all the calls, and in the slave Arduino, we're going to handle the turning on and off of the lights of the elevator and of the floors, and of the activation of our button in the pin 12. Following that order, we can see the call for all the variables that we're going to use during the project, the setup where we establish the level 1 of our elevator, and the call for each one of our functions. We have the void loop, which essentially calls the getAtList function for analyzing which one of the buttons has been pressed respectively during analyze of our Arduinos. After that, we have the getAtList, which is directly in charge of measuring the levels high or low of each one of our buttons, and our getAtList lift, which is going to be in charge of lifting the elevator when it's necessary. We can see that particularly these sections of the code are the ones in charge to sending the message of turning on off the lights to our slave Arduino, where we send like the strip of lights that we want to turn off and the color that we want to send. And now you can see that we're going to work with two different doors, as we have our left one and the right one. In the getAtList door, we are going to still analyze if another button has been pressed, and this new function over here is going to be the one helping us to send the specific lines of information in regards to the NeoPixel that we want to turn on and off in our light strips. Our void listen is essentially the same. We just changed the sections of the NeoPixels where we send an array of information related to this new function, and that's it. Thank you for your attention.